called Union Pacific, a chemistry teacher at Eagle Christian High School. So today we are going to discuss about the industrial manufacture of sulfuric acid using contact process. So contact process is a process used in the manufacture of concentrated sulfuric acid. So you can check on the board. So we have industrial manufacture of sulfuric acid using contact process. So contact process is the one that we are using in this manufacture of this acid, which is concentrated sulfuric acid. So what you need to know, you need to understand the raw materials that are used in the manufacture of sulfuric acid using contact process. So the raw materials are sulfur, you can use sulfur, or sulfides of sulfur such as arena, which is the sulfide. So in air also, so use air or sulfides of sulfur or sulfur. So in this case we are using sulfur and air. So these are two raw materials that we are using in this process. So you can see we have numerous chambers. So we are going to discuss what happens in each and every chamber. So we're going to discuss what happens in each chamber. What is the function of each chamber that you are seeing here on the board? So we're going to know each and everything. So let us start with the burner. So in the burner, sulfur, you can see sulfur and air react together to form sulfur 4 oxide. So the equation that takes place in the chamber is this. So we have our sulfur, which is solid, plus oxygen, which is a gas. So oxygen is the atomic, so it's supposed to be indicated in this way. So then we produce sulfur 4 oxide, which is a gas. So when you check our equation is self-balanced. So there is no need of balance in this equation because it is self-balanced. So the burner, this is the equation that takes place in the burner. Now, after sulfur and air have burned in the burner to produce sulfur 4 oxide, so they are taken into the purifier. So sulfur 4 oxide and air are taken into the purifier. So what happens into the purifier? So this is where purification takes place. So the purpose of the purifier is to remove the impurities which would poison the catalyst at the later stage. So we are going to see the catalyst that is being used. So we will discover that the catalyst that we are using in this process, when the impurities are not removed, this catalyst can be poisoned. So in the purifier we are removing dust particles. So which are the impurities that would poison the catalyst. So now the purified air, now the air and sulfur 4 oxide have been purified. They are taken into the next chamber. Our next chamber is the dryer. So what is the purpose of the dryer? So the dryer is there to dry the gas. So we are drying the gas using a certain drying agent which is common sulfuric acid. So this is the purpose of the dryer, is just to dry the gas. So using our drying agent which is concentrated sulfuric acid. Now the dry gas and sulfur 4 oxide, this is the dry gas which is sulfur 4 oxide in air. So they are taken into the next chamber which is compressor. So our next chamber is the compressor. So what happens into the compressor? So what you need to realize, what you need to know here, you need to know the conditions in the compressor. So in the compressor we have pressure. So a pressure of 1 to 2 atm. A pressure of 1 to 2 atmospheres. So these are the optimum conditions that are necessary in the compressor so that the gas can be compressed. So the compressed gas here, the gaseous mixture, is taken into the next chamber which is the heat exchanger. So in the heat exchanger we also have another condition. So another condition in the heat in the heat exchanger, which is also an optimum condition. So we have temperature. So a temperature of 450 is used in this chamber, which is the heat exchanger. So the purpose of the heat exchanger, so it just comes from the word heat. It's just heating the gas. So the purpose of the heat exchanger is to heat the gas and air, so that gaseous mixture, to provide suitable conditions for the reaction in the catalytic chamber, which is our next chamber. Now you can see now the gases have been heated at this temperature, which is 450. So the sulfur dioxide and air are taken into the catalytic chamber. Mark the word catalytic chamber. So the word catalytic comes from the word catalyst. So in this chamber we have a catalyst. So specifically here, we are going to talk about two catalysts. But one of them is preferred use compared to the other, and we are going to see the reason. So the two catalysts that are used here, so we have our catalysts. We have the catalyst, the two catalysts that are used in this chamber. So one is platinum. Another one is vanadium 5 oxide. Vanadium 5 oxide. So these are the two catalysts that can be used in the catalytic chamber. But we prefer vanadium. So vanadium is preferred use because it is cheap. So it is cheap compared to platinum. Another reason is that vanadium 5 oxide cannot be easily poisoned by the catalyst compared to platinized platinum. So now, in the catalytic chamber, we have a certain equation that is taking place here. So let us check our equation here. So we can check, or we can see our equation that is taking place in the catalytic chamber. So we have sulfur oxide. You can check sulfur oxide, which is here, plus air. Sulfur oxide, which is a gas, plus air, specifically oxygen gas. So to produce sulfur 6 oxide. So this reaction is reversible. So it can go both forward and backward. So it is supposed to be indicated this way. So this equation is reversible. So you need to indicate the catalyst. So you know the function of the catalyst is to speed up the rate of a chemical reaction. So our catalyst here is vanadium, and we have seen the reasons why it is preferred use compared to platinized platinum. So this is the equation now. So you can just balance this one, put a 2 here, and put also another 2 here. So this is the equation that takes place in the catalytic converter. So we are seeing that sulfur 6 oxide is produced. So after sulfur 6 oxide is produced, you can see on our flow chart. So it is taken into the heat exchanger. It is taken into the heat exchanger where it preheats the incoming sulfur oxide and air, and at the same time it can be cooled. So it is taken air from the heat exchanger and is again taken into the absorption tower. So we are going to see what takes place in the absorption tower. So in the absorption tower we have concentrated sulfuric acid. So it means that sulfur oxide, the one that is coming from the heat exchanger, is going to react with the substance which is in the absorption tower, which is concentrated sulfuric acid. So it is common sulfuric acid plus sulfur 6 oxide to produce an oil liquid known as oleum. So to produce oleum. So when you try to check this equation, is self-balanced. So there is no need of balancing this equation. So this is the equation that is taking place in the absorption tower. So from the absorption tower, oleum that has been produced is taken into the dilution chamber or the dilution tower also. So where oleum, you can see this one now. So we have our oleum, the one that has been produced in the absorption tower. Oleum is a liquid plus water. So water is also a liquid. We are producing our common sulfuric 6 acid. Anything that is common state symbols is supposed to be a liquid. Then you can check, you count the number of atoms of elements on this side and number of atoms of elements on this side, then you balance them. So we have 2 hydrogens, 2 plus 2 are 4, sulfur, we have 2 sulfur atoms, we have 1 sulfur atom on this side, meaning the sulfur is not balanced. So when you check oxygen, we are having how many oxygen atoms? 8 oxygen atoms. But when you check on this side, you have 4. So when you check well, or you can also see that a 2 is supposed to be here so that we can balance our equation. So hydrogens are 4 now, sulfur 2 also on that side, oxygen atoms are 8 on this side, and when you check well on this side, oxygen atoms are also 8. So this is the end of our process. Then what you need to know again, you need to know some of the pollutants in this process. So the main pollutant in this process is sulfur 4 oxide, which is being released into the atmosphere. So I think we have seen what takes place in each and every chamber, so that we can manufacture concentrated sulfuric acid using contact process. Thank you.